Hello mathematicians, it's time for another exciting math lesson. Today, the lesson that we're going to be doing is called Fraction Division on a Clock. We are doing Unit 7, Module 2, Session 3. Last week, you remember, we've been dividing and whole numbers by fractions and fractions by whole numbers. So today we're going to pick up where we left off, and here's what I need you to know. First of all, I have a couple of I can statements for you. The first one is that you need to remember this. I can solve story problems involving division of a unit fraction by a whole number and vice versa, and I know how to model with mathematics. So these are two of your I can statements. Two things that you are all very good at doing already. All right, so I want you to think that as we're working, because I know it's true. All right, today, the first thing you're going to need to do, we're going to do a problem string, but we are not going to do this problem string in our journals like we normally would. Instead, you're going to need to take out your student book. All right, take out your student book, and on that, you're going to need page 269, and it will look like this. It looks like a bunch of clock faces because that's the one we need to do. And the purpose of today's lesson is to review the use of visual models when solving whole numbers divided by fractions and fractions divided by whole numbers. So this particular page is called Fraction Division on a Clock, which is where our title came from. I'm going to put this on my clipboard. Nice and up here, and you'll notice that you have 6 different sections of clocks. And what I'm going to do as we do this lesson today, the top 2 will go together, then the middle 2 will go together, and then the bottom 2 will go together. I'm going to read the story problem for you, and what we need to do is we need to write an equation up here. All right, that's what you'll be doing today. So read the story problem, write down the equation. That's your job. And then what we're going to do is we're going to model that. What would that look like? At any point during this, I will ask you to stop, and after we write the equation, I want you to take a moment and try to model it without looking at what I have ahead, and then come back to the video. All right, so it's kind of a way that you'll be able to test yourself and see how you're doing on this. All right, here's our first story problem. It says, how many half hours are there in 2 hours? And I'll show you the problem. How many half hours are there in 2 hours? So now you need to think, how would I write this equation? If you're going to write the equation in here, how many half hours are there in 2 hours? For that particular equation, and I'll take my black Sharpie here, and I will have to turn my board down because I cannot write numbers backwards like this. So how many half hours are there in 2 hours? So I need to take 2 hours, and I need to divide that into half hours, right? So how many half hours are there in 2 hours? That's what I'm trying to figure out. So I'm going to write my label underneath this, knowing that I'm working in hours. All right, now I want you to pause the video here, and I want you to try to sketch a picture that will match that. While you're pausing, I'm going to figure it out. I'm going to take 2 of these. I don't need these 2 because I know that each one of those clocks equals 1 hour. All right, and I'm going to split each one of those clocks into half hours. And if I'm counting those up, I know that I have 1, 2, 3, 4. So the answer on that one is going to equal 4. The answer to that question is there are 4 half hours in 2 hours. All right, let's try the next one. The next one that I have, and again, remember these top two are going to go together, the middle two will go together, and the bottom two. And I'll make one more adjustment on my paper to maybe show you. Now, what we're mostly doing is we want to compare story problems. So the first story problem was how many half hours were there in 2 hours. So this story problem is going to be right here. And I'm going to pull my other paper I have in front of me so I can read it here while I'm showing you the problem. Here's the second problem that we're doing on this. And it asks, what is a half an hour divided into 2 equal amounts? So how would I write an equation for that? What is 1/2 an hour divided into 2 equal amounts of time? Well, first I need to write the half hour down, right? So I'm going to write half hour, and I'm going to divide that by 2. 1/2 divided by 2. And again, I'm going to write my label down here so I know, right? 1/2 of an hour divided by 2. How would I show that? Pause your video and try to do a visual model. And well, I'm assuming that you're paused again. I know that I only need a half of an hour. So I'm going to take 1 clock and I'm just going to split it in half. And now that I have a half of that hour, I need to split that into 2 equal amounts, right? So normally if I do a clock like that, I know that I'm going to have 2 halves right there. But how much time is that? Do you remember when we read a clock how we do that? If I was to split it all the way, my clock would go across there, and I know that there are 4 1/4 that are going to make that equal 1 whole clock. So 1/2 hour split into 2 equal parts equals 1/4, right? That's how much it is. 1/2 divided by 2 equals 1/4. That's how much 1 equal part of that would be split in 2. All right. Our next problem on the next 2, put my papers out of the way. Our next question is going to take place in the middle section. And the next one we're going to ask is, how many thirds of an hour are there in 4 hours? So here's your problem. How many thirds of an hour are there in 4 hours? So you should be pausing your video to draw your picture and write your equation. How many thirds are there in 4 hours? So I need to take 4 hours and divide that up into thirds, right? Oh, wrong pen. 4 hours divided by thirds. That's my equation. 4 divided by 1/3. And let's see what that picture would look like. I want to take each one of those clocks and I want to break them into thirds. And I remember, because it's a clock, we have it broke. It goes 1 through 12. So that means every 4. All right. Each clock should look like this, right? And I need 4 of them, so all 4 of my clocks need to look like that. Again, it's important to be able to do these visual models, mostly because we want to compare these equations later on. Now, to find the answer on that, all I have to do are count those sections, right? But I know that 4 times 3 is how much? 12. So that one is going to equal 12 for my red. There are 12 1/3 in 4 hours. That's what that's asking. All right, let's try this the other way. The next part of this question is going to ask, what is 1/3 of an hour divided into equal amounts of time? Here's that second question. What is 1/3 of an hour divided into four equal amounts of time? I'm not sure if I have the word "for" up there. Divided into four. Should be 4 equal amounts of time. I'm realizing as I wrote that I left out 4 equal amounts of time. All right, so the first thing I need to do is find 1/3 on a clock. All right, here's my example. I'm taking 1/3 right there. And now what I want to do is I want to break that into 4 equal parts. All right, 1, 2, 3, 4. It should look like that. Can you see my clock? 4 equal parts right there. Oh, I forgot to write down my equation on this one. So what would this one be? This equation is going to be, what is 1/4? Oh, I'm losing my equation. I put it over here. What is 1/3 of an hour divided into 4 equal parts? So 1/3 divided by 4. That's my equation on this one. And again, it's easy to figure out the answer because I just need to count it. But is the answer 4? Or is the answer that I have to take all the parts that would be there and then shade in just those parts? 1, 2, 3, 4. I need to shade in those parts. So 4/12 is what that's going to be on that one, right? Or actually, one of those sections is going to be 1/12. So 1/3 divided into 4 equal parts. Each equal part is going to equal 1/4. That's how I do that. I'm going to show you that other little trick here at the end after we do one more problem, just so you can know how to double check. So we'll do the regular algorithm at the end, just so I can show you how to do that. All right, we have 2 more problems down on the bottom here. The next problem says, down for this one right here, how many quarters of an hour are there in 3 hours? How many quarters of an hour are there in 3 hours? So for this part, my question, I need to take 3 hours, and I'm dividing 3 by 1/4, right? And 1/4, I know on a clock, is like 1/4. Right? 1/4 is 1/4. So let's take 3 of those and divide 3 clocks into 4ths. And really, all these questions are asking, what is 1 unit of this equal? I'm going to count all those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one of those is 1/12. Oh, I'm sorry, not 1/12. There are 12 in 3 clocks. That's what I need to know. So this one equals 12. Equals 12. There are 12 1/4 in 3 hours. That's what that question is answering. All right, so the last question, if you figured out the pattern that I'm doing on this now, you can see that the last problem I'm going to ask has to do with taking 1/4 and dividing it into 3 equal amounts of time. And that is exactly what the question is that the curriculum is posing. It says, what is 1/4 of an hour divided into 3 equal parts? All right, so for this one, I just need 1 clock, and I need to take 1/4, and I'm going to write my equation 1/4 divided into 1/4 divided into 3 equal parts. Right, there's my equation right here. And I'm going to take this and I'm going to divide it. And again, I need to take, in order to figure out the whole amount, this is kind of like how when we had brownies, right? Oh, I don't think you can see me there. When we had the brownies in a pan, even though some were gone, we have to figure out how much that little amount is representing on the whole clock. So that's why I'm adding all those extra lines. So one of those section, 1/4 of divided into 3 sections is actually going to equal 1/12. Okay, now what I want to do is I want to show you, great, I'm putting those on the wrong things. I'd like to show you, and I don't think I have another pen that will show up very well. I don't know if this green, that's a brush, that's not going to work. See if this green shows up. All right, so if we're doing on the first one, I want to do the straight up algorithm. All right, let me grab my story problem papers here. And we're going to go back to what we learned back in the end of January. I can't remember the date now, looking at our book from last week. I think it was on the 27th. How many half hours are there in 2 hours? We said 2 hours divided by 1/2, right? We did our visual model on the clock paper, but how would we solve the algorithm here? You might remember when we were doing these division and multiplication problems, I told you that what you need to do, it would be like 2/1 divided by 1/2, which is the same as 2/1 times, and we flip the second one, 2/1, right? And we straight multiply across like this. What ends up being 4/1 or 4. So if I double check in our paper, we had said that 2.5 divided by, or 2 divided by 1/2 equals 4. So that's doing it in the standard algorithm way. Again, is there a right way and a wrong way to do this? No. There are many ways that you can do these. So usually, as your parents probably grew up knowing these as the standard algorithms, the way that we need to do them is by being able to model our thinking, because sometimes on those tests called the iLearn and other things, it might ask you to show your thinking. And that is why I need you to be able to do it this way. So when we're multiplying or when we're dividing, remember we change the division sign to a multiplication sign, and that's when we flip the other number. So, and we can do that with all of these. Let's take our third one, just to give it a try. We'll do the last one. All right. What is 1/4 of an hour divided into 3 equal amounts of time? All right, here we go. What is 1/4 divided by 3? And I know that might not show up very well on my camera there, but that's what I'm doing. What is 1/4 divided by 3? That is the same thing as saying 1/4 divided by 3/1, right? 3/1, which is the same thing as saying 1/4 times 1/3, right? Because we switch it, we use that multiplication now, and we flip the numbers, and then when we straight across multiply, equals 1/12. So here I have a visual model of it, and here I have the algorithm. Not bad. They ask now on the next part, what kinds of things do you see? What patterns are you seeing? Remember, I'm always asking that in class. What patterns are you seeing? I want you to use your math brain and start to think about patterns. So look, I wrote down all the different equations that we did here. I did the first line, the first 2, and then I did the second 2, and then I did the third 2. So I want you to look at both of those, and I want you to think deeply about this, all right? Here's my first question. When is the quotient, or the answer, less than both of the numbers in the combination? And why is that the case? The next question I have is, when is the quotient greater than both of the numbers in the combination? And why is that the case? And then from this, I want you to take the big idea, because this is what it's all about. It is something that we've been studying for months, believe it or not. I probably have to look at my card when I'm reading it. So our big idea, when we divide a whole number by a fraction, the grouping interpretation makes good sense. And when we divide a fraction by a whole number, the sharing interpretation makes good sense. Again, this is going to go right back to our math journals. I think I can pull mine up pretty quickly. And I'm going to show you back on January 27th when we did this, where we were doing grouping versus sharing. And that is what this is all about. So when you are dividing, but again, here's the words. When you're dividing a whole number by a fraction, it's better to do grouping or to think about it in terms of grouping. And when you're dividing a fraction by a whole number, it's like thinking about sharing it. So I could share this. Here I'm looking at, on all of these problems, I'm looking at grouping. How many groups can I make? How many shares would each person get if we were going to give time to each person, right? How many groups can I make here? How many shares could I have here? Works better if I think about this in brownies, right? Because I want to share brownies. I don't really want to share time. But I think you can understand what I'm saying there. How many groups could I make? Whole number divided by a fraction. How much sharing can happen? Taking a certain amount and breaking it into groups, I need to share on that. And that's the big idea for today. Now, for your homework tonight, there's no homework per se. There is a student book page that you need to do, and I'll have that in your directions, but it is student book page 269, so only one student book page. However, if you want more to practice on your division, there is a game that clearly I'm not going to introduce since you don't have my materials at home. And quite honestly, I don't have all my school materials here at my house. If you have a deck of cards, though, you could modify and you could play the game. The game is actually on page 270 and 271 in your student book. And if you would like to read through the directions and figure out how to play that game, you should do that. So you would just take the face value of the cards and you're working on division problems, dividing 3-digit numbers by 2-digit numbers. That's what that is all about. You do not have a home connection tonight for homework. However, you do have spiral review. And this week we're working on Q 4.1. So quarter 4 and the first one. All right. Thanks, mathematicians. Get going on your student book. Let me know if you have questions. All right. Send me a message.